updated this machine. And they updated this machine. All my previous settings are out the window. All right, those in Zoom, please be sure to start putting your names in the chat. Those in Zoom, can you hear me? Yes, no, maybe so. More importantly, or just as important, can I hear you?
Yes, we can hear you.
All right, thank you. All right, now I'll be right back. It's not doing it. It's not doing it. Why are you doing it? So there are no presets in the stupid camera anymore. This. And I'm gonna do this. Oh, that's the wrong slide. This was the correct. Yes. Okay, so. I'll be right back. Already. All right, thanks. I told us that it was supposed to be August. Whatever. I have all y'all's exams graded. I just haven't posted the grades yet. And today that's what I'm gonna do today. And also post the graded exams back into the assignments. I have not found a way to, no. In the last week, I realized I have that tablet I bought, paper tablet I bought. I can use to grade the PDF files y'all upload. I should have been doing that all along. Makes things so much quicker, easier. It's like grading an exam, paper exam. Okay, here's the deal. I don't think, well, it was kind of in this class as well, but not as bad as in my college algebra classes. I say show all your work. You need to show all your work. I had one person in my college algebra classes, they got all the right answers, but they didn't show any work. None whatsoever. So out of 135 points, they only got about around 50 of them. Because I only give you 2 points for a correct answer if you don't show your work. Show your work. I tell that in the instructions during the test. I constantly post it in the chat. Please show your work. For those of you who do that, thank you. For those who don't, start doing it, because you lose points, lots of points, if you don't show your work. And when you do, please make sure that it's somewhat neat, a lot neater than what I do on the board, because there was one person, they were worse than I was. I had to hunt down, they worked a problem on a sheet of paper up here, and then down here, and then down over here, and so it was inside other problems. And so, you know, no. Anyway, it makes it hard for me to grade and slows me down quite a bit. Another thing that slowed me down is I didn't, not on this exam for y'all, but for my college algebra classes, I had, there were only three problems, but on 2 of them, there were 8 things to do. And on 1 of them, there was 12 things to do. But the function I gave them, there were typos. There were bad typos. And so it made the problems just a little much more difficult than I had intended. And so I tried, and I say tried. I noticed the typos, and so I write on the board. I tell people, I'll mute myself and tell people, this is for problem 3, this is the function. For problem 2, this was the function. There was a typo. Use this function. They don't. It's crazy. Either they refuse to listen to me or they don't look at the chat during the test. So I don't know. Anyway, and also there was wholesale cheating in one of those classes. It was really bad. But here's the problem. On most of the people who did cheat, they did not, whoops, wrong way. They did not, oh, I know. They did not show their work. one person, because I had not covered this in class, so I don't know where they got it from. They had solved the problem by completing the square. Part of the problem, they solved it by completing the square. I showed that in class one day, but I did not expect anybody to use it because you can use the quadratic formula, which if you need, I'll write on the board for you. And the way it was written down, it obviously was copied off of something I found on the internet. But I can't prove that, but there were several steps that there were some, what do you call it? Transcription errors. And then to get from this point and that what they did to this point and they did, there's a couple of steps they should have showed me. And so I lost points on that problem anyway, but. Technically, I could have given them a 0 for the exam and had them prove to me that they didn't cheat. My wife says I'm too nice. Okay. So what we did last time was about if we have X and Y and we want to put it into polar form, which is the radius and the angle, then we use our cosine theta and our sine theta. Well, actually, if we want to go back, this is the process. So R is x squared plus y squared square rooted. And cosine is x over r. So if we do cosine inverse of x over r, we get theta. Or if we do sine inverse of y over r, we should get the same theta. And doing it in a calculator, you might be a decimal place or two off if you go down far enough. But essentially, they're the same angle. And so you have this process here to convert between x, y, and r theta. And so here we have this, according to my notes, this is the slide we ended on. And so, yeah, looking at this point, pi over 4 is this angle. And so if the radius is 2, they want to know what these points are. So our cosine pi over 4, or 2 times cosine pi over 4, and 2 times sine pi over 4 gives us the x and the y. So what are the x and the y? What is cosine of pi over 4? That's one of the angles. You should have these two measures in your head already.
Square root 2 over 2.
Pi over 2, square root of 2 over 2. So you have 2 times the square root of 2 over 2, and 2 times what?
Square root of 2 over 2.
Square root of 2 over 2, because at pi over 4, cosine and sine are the same number. So that's just the square root of 2, and that's just the square root of 2, because these go to 1. So this is the square root of 2, and this is the square root of 2. So this point here is the square root of 2, comma, square root of 2. I had a professor who always ended up writing ordered pairs as a multiple of a unit vector. Don't ask me why he always did that, but there are times where you want to do that. But he did it always. I understand why. When he thought mathematics, he thought way up here, where I'm just down here. Okay. So. Oh. Where's my, there it is. I'm a little scattered this morning. Because I finally got to the groove of grading, and I got one more class graded. It took me a while to get things settled down. I had to write 2 or 3 versions, well, 3 versions of the exam, of the 3 exams I gave my college algebra. My pre-calculus classes, I'm done grading it. I just need to post those grades. So I finally made the 3. And inside each of those 3, there on one of the problems, there were 2 versions because of the mistake I made, and people weren't listening to me. Yeah, and this does lie in the first quadrant because they're both positive. The X and the Y. Okay. We're going to do the same thing here. So -2 times the cosine of a -pi/6, which is a -2 times the cosine of pi/6, right? Whenever you see cosine of a negative angle, you can write it as cosine of the positive. It simplifies your work. And so the sine comes from which quadrant this angle is in and what you're multiplying the cosine by. All right, this is in the first quadrant. So that's going to be a positive cosine, but multiplying by a negative. So it's going to be a -2 times whatever cosine of pi/6. Okay. So this is what we have. Pi/6 is this angle, -pi/6. But the radius is negative. So that means we want to go in the opposite direction. So that's going up this way. So we're going to deal with this point over here. And because now that's a -2, where a +2 takes us down into this quadrant. So my sine is negative down here, and the cosine is positive over here. But if here they switch. Now the sine is positive, but the cosine is negative. Well, yeah, I'm going to get a negative value for my x value. Right? Because now my x comes along here and it's negative. It's less than 0. And my y value, which is along here, is going to be positive. So now I'm going to do a -2 times the sine of -pi/6, which is the same as, because the sine of a negative is the negative sign of the positive, so this is a -2 times the negative sign of pi/6. Negative times negative is positive, So that's gonna be 2 times whatever the sine of pi over 6 is. So we're looking at this angle here. The unit on the unit circle. What are my x and y coordinates of the unit on the unit circle of pi over 6? One of them is 1/2 and the other one is the square root of 3 over 2. Which is it? And I keep telling y'all, knowing your unit circle is very important, very helpful, especially the first quadrant. No, I'm a little hyper today, so. Square root of 3 over 2, 1/2. The x value is the square root of 3 over 2. And the y value is 1/2. So our x value is a negative square root of 3, and our y value is 1. So this point here is the negative square root of 3, 1. Okay, questions? Questions?
Why would the sine be negative and the cosine be positive?
Well, cosine is an even function. So cosine of the negative is the same as a cosine of the positive. Okay. That's why we can write it this way. And the sine is an odd function. So the sine of a negative is the negative sine of the positive. Right? Because if f is an odd function, f of negative x equals the negative of f of x. Remember, sine, cosine, and tangent, and all those are functions. And so that's what happens. So is that what you're asking? Okay. So knowing the even and odd nature of sine, cosine, and tangent, and the reciprocal functions, follow the same pattern. That's when it's an odd, and when it's even, f of negative x equals f of x. This is straight out of college algebra. Any other questions here? Science teacher. Okay. So use the conversion formula. Lies in the second quadrant, right? So that means that x is going to be negative and the y is going to be positive. Okay. And yeah, so this right here is what I have right here. They didn't use the odd and even nature of cosine. Right. And then they got the negative square root of 3 right here, which is underneath what I wrote there. And then our sine theta, they get the same thing. And that point lies in the same quadrant as expected. Any questions? erase what I've written. I think using the odd negative, the odd and even nature of the trig functions simplifies matters. It adds a step in the calculations, but it simplifies what's going on. Right away, I know the cosine of a negative angle is the cosine of the positive, and the sine of a negative is the negative of the sine of the positive. So since I know that relationship, all I need to know is my first quadrant, and then just what's the sign on the outside? Which quadrant am I going to end up in? Now, to find the polar coordinates of 0, 2. Well, let's see how they do it. Well, I start by graphing this silly thing. Let me just do that. 0, 2. That's on the y-axis. That's the angle pi over 2. So I know the angle. So now all I need is the radius. Well, the radius is x squared plus y squared square rooted. So 0 squared plus 2 squared square rooted is the square root of 4, which is 2. So r is 2, and theta is pi over 2. So the point here is 2 pi over 2 in polar coordinates. So if I have polar coordinates, if I have a polar coordinate chart or graph, this is pi over 2, and I come out at 2 units. So, okay, yeah. I did the same way I did. Plot the point, rectangular coordinate system, see the figure. The point lies on the positive y-axis, which is pi over 2. If it was a negative 2, then it would have been down here on pi over 3 pi over 2. And our distance is a positive 2, 3 pi over 2, or I could write it as pi over 2, but then my r is a negative 2, because if you recall, there's more than one way to write the coordinates of that point. So the point 0, 2 lies on the y-axis, a distance of 2 units from the origin, the pole. So r is 2, which is easy to see once you plot it. A ray with a vertex at the pole forms a 90-degree angle, which is pi over 2. And there we have it. So the angle is what ray are we talking about? How many degrees or how many radians are we coming off the 0 angle, either in a positive direction or a negative direction? That's what ray we're looking for. That gives us the angle. And then how far along that ray we are is the radius of the circle. that has the center at the pole. Okay, please notice they represent it in two other ways. And there's more ways. I could have done -2 3 pi over 2, which was my natural inclination to say. Which is these two angles wind up at the same place. -pi/2 and 3 pi over 2 are down here. See, one goes like this and the other one goes like this. So they wind up at the same rate. And then you just go 2 units along that. Well, -2, which takes you in the opposite direction. And then this is, you go around once, and then you come back to it. So 4 pi over 2 is once around, and then you add in another pi over 2. I could have gone 7 times more. And so that would have been 15 pi over 2. And you could have gone 235 times around. I don't know what that is. But anyway, I just multiplied by 2 and had 1. All right. So the figure shows polar coordinates of the points that lie either the x-axis or y-axis. And depending upon which side of the origin the point lies, denotes the sign. Well, no. So if it's A0, then R theta is A0. If it's on the y-axis, the positive y-axis, then it's A pi over 2. If it's on the negative x-axis, then it's A. Well, the A is negative, because here they're saying if A is positive. So they're adding this stipulation that A is always positive. So if you want to talk about the negative, you put a negative sign in front of it. And so A going negative this way, the radius of the circle is still A units, but the angle is at pi. So I went 2 units this way. Even though in the coordinate system, it's negative. And so same thing here. Since it's on this ray, the A will be positive. Right? If we're talking this angle, but we're talking about a negative A, then the point would be up here. And so that's what happens with the coordinate system and the quadrantial angles. Right? Quadrantial angles are 0, pi over 2, pi, and 3 pi over 2. And sometimes we include 2 pi, but 2 pi is the same as 0. All right. In absolute value terms, these two angles are the same. I mean, these two numbers are the same, right? So that's one of the 45-degree angles. So it's either pi over 4, 3 pi over 4, 5 pi over 4 or 7 pi over 4. So it just depends on which quadrant we're in. First quadrant, second quadrant, third quadrant, or fourth quadrant. The quarter pi angles. So 3. So I look at this in the coordinate system, that's this point over here. Where this is -3 and this is +3. So -3 and +3. So all we need to do now is find out what R is. Three squared plus -3 squared, square root. When you square a negative number, what happens to the negative sign?
Becomes positive.
Comes positive. You know why I ask this all the time? You know why I ask about squaring a negative all the time? Because I still have people not squaring it properly. This is one of the things you need to get into your head. Is that when you square a negative, it always becomes positive. So that's 9 plus 9, so the square root of 18 is 3 square roots of 2. All right, knowing your first 16 perfect squares comes in very handy when you simplify a square root. 18 is 9 times 2. I know I picked 9 times 2 rather than 3 times 6 because 9 is a perfect square. The square root of 9 is 3. And 2 doesn't have a perfect square, is not a perfect square, so we just leave it as a square root of 2. So I know my R. Oh, I hit the button, didn't I? So R is 3 square roots of 2. So we're in the fourth quadrant. Oh. Seven pi over 4. Okay. All right. If you did not know that, and this would be -3 over here. So here I have the angle, my angle theta. And I can do tangent of theta equals a -3 over 3, right? Y over x, which is a -1. So then I do tangent inverse or arctangent of -1, which is well, since we're dealing with this quadrant, because this gives me 2 angles. It gives me 3 pi over 4 and 7 pi over 4. And since we need to be in the fourth quadrant, it's going to be 7 pi over 4. And if you do it in your calculator, you'll get a decimal number. So just divide that decimal number by pi, and that'll give you approximately 7/4, which is 1.75. So you will end up getting 1.75 pi. Because you're dividing pi out, you have to multiply it back in. Oh, I forgot the 5. which is 1 3/4 pi, which is 7/4 pi, which is 7 pi over 4. If you write it this way or this way, I don't care. So we're gonna see how they do it. So plot the point and note the quadrant the point lies in. Okay. So that's always the first thing I do. I draw a picture. One of the best advice my Calculus 1 teacher taught me at UTSA was pictures never prove, but they help. It's amazing how much a picture can help you understand a problem. That's one of the methods of problem solving. When you're setting up the problem, setting up all your information, one of the things you do, you draw a picture if possible. Well, with this, yeah, you can draw a picture real quick, real easy. Right, determine the distance. Determine R. So find out how far the point is from the origin. Okay. They did it exactly the same way I did, because that's the only way to do it. Actually, there's probably other ways, but this is a quick and easy way to do it. Determine theta. Yeah. And so they're doing it this way, where tangent is between -pi/2 and pi/2, which is but we want -pi/2 and 0 because we want the fourth quadrant. They're going to write it as a negative angle. I prefer to write them as positive angles, but it doesn't matter. Either way, it works. So, okay, so the next slide, they talk about that. -pi/4, which is 7 pi/4. So if you type it into your calculator and you get a negative decimal number, then just divide it by pi, and you should get 0.25, -0.25. Or something very close because of rounding. The only difference between the way they wrote it and the way I wrote it is they used the negative angle. They used the negative angle where I used the positive angle. Do they throw that in there? Yeah. This one. Or they went into the second quadrant and made the radius be negative. Okay. Because the point we're talking about is down here, but if I only go this far as my angle is concerned, then I need to go in the opposite direction, which makes R negative. So this would make a negative part, because R would take us over here, but we need to be down over here. So we want to go in the opposite direction, which means R is negative. Remember, when we're talking distance, negative sign means which direction. Talks about direction. The length is still the same, but the direction is opposite. Wait, they're going after all the 45-degree angles. If the two numbers are the same, or if their absolute values are the same, then it's one of the 45-degree angles. All right, -2, -2. What quadrant is -2, -2 in?
Third one.
Third quadrant. So we're talking this point here. So either theta is going to be this angle, or theta is going to be this angle, and it will be negative. But in any case, if I subtract these two, I'll get 2 pi. Either a -2 pi or a +2 pi. But so what is R? R is the easiest of the things to find. Tell me how to find R.
-2 squared plus -2 squared.
This is incomplete.
Square root.
Square root, right? So you have 4 plus 4, so you have the square root of 8.
Which equals 2 square root of 2.
2 square root of 2. So this distance, so this R is 2 square root of 2. All right. So I know X and Y, so I can use tangent. Tangent of theta equals a -2 over a -2, which equals 1. So that means I'm going to do tangent inverse of 1. All right, tangent inverse of 1. Tangent is positive in the third quadrant and the first quadrant. Okay. So I'm going to find it in the first quadrant and then just add pi to it or subtract pi from it. You either do pi plus theta or theta minus pi. To get the negative, you want theta minus pi. And so we're actually going to find this angle here, and then we're going to either add pi to it or subtract pi to it. And dollars to donuts to dollars, you're going to get they're going to do the negative. But since we're in this quadrant, we want from negative pi over 2 theta less than negative pi. I think that's what they're going to use, which is here. We're talking in here. Where I would think about going this way, so that would be pi to 3 pi over 2, but they're quite fond of using negative angles. So when they're equal, it's one of the quarter angles, one of the 45-degree angles, either pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4. So, but these two, this one would be a negative 3 pi over 4, and this one would be negative pi over 4. Since we're dealing down here, we're going to use this angle. So that equals a negative 3 pi over 4. And so what was R? 2 square roots of 2. And the angle is a negative 3 pi over 4. Or we could do 2 square roots of 2. That same angle is 5 pi over 4, gets you to the same ray. And then there's other versions. If I wanted my radius to be negative, then I would have to be in the first quadrant. So I could go across, come up here, and then come back this way, down to there. And that's just 3 different ways of stating that point. So you find a way that works for you and stick with it. Unless my map wants to mess with your head and wants to do it a certain way. Personally, there's not a definitive answer here. They're all the same point. It just depends upon how you're looking at it. Let's see how they're doing. Yeah, third quadrant. And they got square root of 2 over 2 square root of 2. All right, so here they want tangent to be in this quadrant. I mean, in these 2 quadrants. So that means they're looking for this one here. Because when you type it in, when you take tangent inverse of 1, you're going to wind up in this quadrant. Just like if you do tangent inverse of -1, you're going to wind up in this quadrant. And so then the sign, you need to be worried about the sign of your radius. Am I going the same direction of that angle, or am I going in the opposite direction of that angle? Or that ray, I should say. And so, okay. Yeah, so they're going to do what I had suggested, is you find this angle and then you add pi to it, which is what they're talking about here. The inverse tangent function gives us an angle in the first quadrant, and then you add pi to it to get the angle in the third quadrant. So that'll give them this angle here. And this one and this one are just as valid, and there's more ways of writing it. So other possible representations are what I had given, negative square root of 2, negative 2 square roots of 2 pi over 4, which is this one, and then using negative. Please ask me questions or slow me down if I'm going too fast. I have a tendency to amp things up, especially when I'm tired and on caffeine. no longer warm. Okay. Okay. So the process we've been doing is what they're showing here. If it's in the first quadrant, then it's just tangent inverse of x, y over x. If it's in the second quadrant, then it's pi plus negative the inverse tangent of y over x. And if it's in the third quadrant, again, it's plus. So if it's in the second or third quadrant, you're adding pi to the tangent inverse of y over x. And if it's in the first or fourth quadrant, then it's just the inverse tangent. Because in the calculator, the inverse tangent takes you into these two quadrants. So if you know where you're going to wind up, and you will know where you're going to wind up because you're told what x and y are, then you know whether you need to add pi or not. In these two cases, in letter A and letter C, the tangent will be positive. And in letter B and letter D, the tangent will be negative. Because tangent, all the trig functions are positive in the first quadrant, and tangent is positive in the third quadrant and negative in the other two quadrants. Okay. And no, I will not give you this formula chart for on the text. This is one of the things you need to squirrel away in your head. Which means you make up problems to work. And if you're having issues with it, then you email me or you go to the math tutoring lab or to the STEM lab. To see what's going on. Okay. Converting from rectangular coordinates to polar coordinates. If P is a point, X, Y, the polar coordinates if R equals Y, which means X is 0, then theta is pi over 2 or negative pi over 2, depending upon if you're above the x-axis or below. And yeah, okay. So that's basically what we've been dealing with. And this is if it's on the y-axis. And you can't use tangent if it's on the x-axis. If r equals x, it means the y value is 0. Then theta either equals 0 or pi. So that's something to consider as well. Plot the points. Okay, so the steps in converting rectangular coordinates to polar coordinates. So you plot the points. And on step 2, if x equals 0 or y equals 0, you use the graph to find r. because R is the non-zero coordinate. If X is 0, then R is Y. If Y is 0, then R is X. But if neither one is 0, then you do what we've been doing. R equals the square root of X squared plus Y squared. All right, if X is 0 or Y is 0, then it's a quadrantal angle. It's either 0 pi over 2 pi or 3 pi over 2, or sometimes they'll say that as negative pi over 2. If X and Y are not 0, then you know which quadrant the point lies. And so if it's in quadrant 1 or 2, this is what was saying before, then it's theta equals the inverse tangent of Y over X. If it's in 3 or 2 or 3, then you use pi plus the tangent inverse of Y over X. And that'll give you your theta. Sometimes the angles aren't one of the angles, the typical angles we've been using. Pi over 6, pi over 4, and pi over 3. So you're going to get your answer in radians. Which is a decimal number between 0 and 6 point something, whatever 2 pi is, 6.283. Okay. Oh no, I didn't get this far. I tried correcting a lot of these earlier. What slide is that? 521. Oh. It's the right button. Stay awake enough for you. Okay. Now to transform this from an equation in polar coordinates to an equation in rectangular coordinates. Ay, ay, ay. This is a little more complicated. Multiplying each side by r makes it easier to apply the formulas. So we get r squared equals 4r cosine theta. Is that right? If I multiply this side by r, I get r squared. If I multiply this side by r, doesn't matter where I put the r because I can use, and so I know this right here, that right there is x. So I have 4x. And now r squared, well, that's x squared plus y squared. Dun, dun, dun. So now I'm going to subtract x squared from both sides. So now I have y squared equals x squared, a negative x squared plus 4x. And then I square root both sides, so I get plus or minus the square root of a negative x squared plus 4x. Now, they may go ahead and do something here. From here, subtract the 4x from both sides. So you have x squared minus 4x plus y squared equals 0. So this is an equation of a circle. If I do completing the square here, I get x squared minus 4x plus 2 plus y squared plus 4, sorry, equals 4. And so this is going to be x minus 2 squared plus y squared equals 4. So this is the equation of a circle centered at 2, 0 with a radius of 2. I can write this as y minus 0 squared. So that gives me my x and y coordinates of the center of the circle. So at 2, 0, I have a circle that looks like this. Looks like a distorted Pokemon ball. And yes, I've been playing Pokemon since whenever the damn thing came out. Well, not that long, but about 2 or 3 years after it came out. It's my children were really into it, so I started playing with them. Anyway. So let's see, I completed the square here. I take half of -4, which is -2, and I square it, and I add it in here. And since I added it to the left-hand side, I have to add it to the right-hand side. And completing the square means that this is x minus 2 being squared. Gives me this. That's what we mean by completing the square. We're squaring a binomial to get this perfect squared trinomial. Completing the square, that's a technique that comes in extremely handy. So I don't know how they want you to write the function. I would either write it this way or this way. They both give you a circle. The plus on this gives you this semicircle, and the minus gives you its mirror image down below, with the center of for both is at 2, 0. So this is a radius equals 2. And theta, well, you change theta. You're finding r by changing theta, because r, the distance from here changes depending upon what angle we're using. And since cosine is positive from pi over 2, negative pi over 2 to pi over 2 is positive there. So we're talking about this space. So let's look at what they did here. So multiplying both sides by r, we get r squared equals 4r cosine theta. Well, x squared plus y squared equals 4x, right? Because r squared equals x squared plus y squared. and r cosine theta equals x. They didn't put that explanation in there to say how you got there. This is the equation of a circle. Proceed to complete the square to obtain the standard form of the equation. So you subtract 4x from both sides. And they group these together because we're going to complete the square in here by adding 4 in here and equaling and adding 4 to 0. And then completing the square in here means that binomial. And there we have it. This is a standard form of the equation of a circle with a center at 2, 0 and a radius of 2. Now, how do we get that 4? Well, to complete the score, if you have x squared minus bx or x squared plus bx, it's the same process. You do negative b divided by 2 squared. Well, and that'll give you what you're going to add here. And if it was plus b, then it's b over 2 squared. And that'll give you what you're going to add here. But half of b is what you're doing, is what you're adding to the x. So whatever you get here, so in this case, you get a negative number, so it's going to be x minus, and here you get a positive number, so it's going to be x plus. So if this was a negative 4 here, then that would be plus, and that would be plus, and that would be plus. And so that means it'd be a negative 2, 0. So it would be, the center, instead of being on this side of 0, it will be on this side. It'll still be the same circle, it's just on the other side of the y-axis. Change it from rectangular to polar. So x equals r cosine theta, y equals r sine theta. So now we have, and first thing I would do, I would divide both sides by 4. But let me see what they do. Let me see what they do. So, yeah, they're replacing x and y with r cosine theta and r sine theta. So you get r squared, 4r cosine times r sine equals 16. So you get 4r squared cosine theta sine theta. Divide both, and then I would divide both sides by, why that? Oh! Double angle theorem, right? They factored the 4 to 2 times 2, and they migrated one of these 2 times the cosine sine. So now I can use one of the, so you still need to use your trig identities. This is sine of 2 theta, because we typically want our trig functions to be written in one trig function, either sine or cosine or tangent. And then I would divide through by 2 at this point. But they're not going to. Why? Okay. Boolean. And because very often we're solving for R. When it's written in a trig function, is usually some form of R equals. But they're not doing that here. So equations and graphs. Oh, this is fun. This is the fun stuff. Identify and graph polar equations by converting to rectangular equations. Test polar equations for symmetry. And then graph polar equations by plotting points. This is how we graph polar equations. We graph points. So we find points. So that means I'm going to look at the unit circle angles to help me graph these things. If your graph isn't big enough, then it can get quite messy. But yeah. So the polar grid kind of looks like a bullseye. And so each circle is radius 1, radius 2, radius 3, radius 4, radius 5. Okay. So they're 1 unit apart as far as, so they're concentric circles that are their radii are 1 apart. Now, so, and they did every 15 degrees. So this is pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12. Because those and then in the negative direction as well, or still going in the positive. So either way, so 15 degrees of pi over 12 is the same. So each one of these is 15 degrees apart, or pi over 12 apart. Okay, an equation whose variables are polar coordinates are called polar equations. The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. Just like with rectangular, in the rectangular, an equation of variables who are rectangular coordinates, then the graph is a set of all ordered pairs x, y that satisfy the equation. It's just the same thing, except we're using the polar coordinates and the polar equation instead of the rectangular coordinates and the function in rectangular in terms of x and y. That's easy. Radius. The radius is 4. So that's just a circle with a radius of 4. right? Convert the polar equation to rectangular form. So that's x squared plus y squared equals 4, right? R is x squared plus y squared square rooted equals 4. Right, r squared is going to equal 16. So we want to square it because we don't want to have a square root in our polar coordinates. And r squared is x squared plus y squared. So x squared plus y squared equals 16, which is a circle. Satisfies that equation. The radius is 4. We don't care what the angle is. So it's all the angles. All right, now graph the equation. Oh. That's a ray. All right, so well, let's look at that. So convert to polar coordinates. I mean to rectangular equation. So okay. So we're going to take tangent of both sides. So tangent equals x over y. Okay. The tangent of this is -1. Okay. Because we're in the second quadrant. And since we're in this quadrant, this is going to be a +1 over a -1. Right, where y equals a -x. That's our equation, y equals -x, where. But we need a stipulation on what y has to be. Oh, they don't care. Okay. So there is no stipulation on r being positive or negative, so it's the entire line that includes the ray 3 pi over 4. Okay. Any questions here? Okay. Now this is where it gets interesting. Well, what is r sine theta? It equals y. So this is just y equals 3. Boom, done. That was an easy one. So if we graph it in the polar coordinates, and you look at each of these angles here. So where the ray hits this, the R and the theta will satisfy that equation. R times sine of theta equals 3. So if I want to find out what this radius is here, then R sine theta, so R sine of that equals 3. So I divide 3 by the sine of this. And the sine of that is the square root of 2 over 2. You get an irrational number, but that's okay. Just be sure you rationalize your denominator. That's what a few people did not do, was they did not rationalize their denominator. Always rationalize your denominator. So this is the same thing, but it's just with x. So x equals a -4. So now this is a vertical line that is 4 units away from the pole at pi. So when theta is pi, there we have that vertical line. Let A be a real number. And R equals sine theta equals A is a horizontal line that lies A units above the pole if A is positive, and A lies absolute value of A units below the pole if A is less than 0. And the same thing happens with R cosine theta. If A is positive or non-negative, then it's to the right of the pole. It's a vertical line to the right of the pole. And if it's negative, then it's a vertical line to the left of the pole. And that's what we just got through seeing. Okay. Identify and graph the equation. What do you mean identify? All right, this is going to be well, I would multiply both sides by R. Let's see. Yeah, multiply both sides by R to convert it to rectangular coordinates. So you have R squared, which is x squared plus y squared, equals 6 times y. Right? And then you complete the square. Right? I take half of -6. So -6 divided by 2 squared. So that's going to be a -3 squared. I would first do the division before I square. because this is what x minus 3 now. That equals a positive 9. So I'm going to add 9 here, and I'm going to add 9 here to get this lovely thing. So now this factors to, oh, that's supposed to be a y here. Y minus 3 squared. That's why I keep the sign with the 6. If this was a negative 6 here, so that would have been a plus 6, then this would have been a plus 3. And so now we have x squared plus that equals 9. The circle is centered at 0, 3. So that's up here with a radius of 3. Because this is r squared, so that's going to mean r is 3. I've yet to draw, well, no, I take that back. I've drawn a perfect circle maybe 3 times in my 30 plus years of teaching. Okay. So yeah, all right. You know what? I've been using that eraser. I found my fuzzy eraser. It was at home underneath my desk, shoved all the way forward where I couldn't see it. So I was blaming some unknown assailant for stealing my eraser when it was my fault. Okay. And there you go. Oh man, that doesn't look like a circle, does it? It kind of looks like an oval a little bit, a little like an ellipse. It looks like it's narrower this way than it is this way. That's an optical illusion. Okay. I love optical illusions. Teaching high school, I used to freak my students out by putting them up there. Okay, a little time. Getting close. So this thing, again, we would multiply both sides by r. And so this becomes x squared plus y squared. This becomes a negative 4x. So now we're going to add 4 to both sides. 4x to both sides. So now I'm going to take half of 4 and square it. So that's going to be 2 squared, which is 4. So I'm going to add 4. So that means this was x plus 2 squared equals 4. X2 squared plus y squared equals 4. Now this is centered at, I set x plus 2 equal to 0, so x is a negative 2. So it's centered at negative 2, 0 with a radius of 2. Because this is r squared. And there's a nice little picture over there. Now this one looks closer to being a circle than, but it still looks a little squashed. But it's not. So suppose A is a positive real number, then the equation is a circle of radius A centered at A0. If R equals a negative 2A sine theta, then it's centered at 0, negative A. If it is 2A cosine theta, then it's centered at A0. And if it's negative 2A cosine, it's a negative A0. Notice the pattern. All right, with trig functions, it's always a pattern. In mathematics, that's what we look for. We look for patterns. And we come up with ways of describing the patterns using mathematical functions and whatnot. My life's good. When I taught in Poteet, I always had one of these in my hand. Always. Always, always, always. But that was back before I had diabetes, so I drank the full octane version. And I went to a faculty meeting one time without it. And several people said, "Mr. Reed, you okay? You don't have your Big Red with you?" I said, "Yeah, I left it in my room by accident." So cool. Okay. Yeah, I used to tell people, my students, that my blood is red not because of hemoglobin, but because of Big Red. Anyway, I appreciate you laughing at my stupid jokes. Okay. All right, so. Okay, those are cool. Try and have those reside in your head. Comes below. Symmetric points. Is it symmetric? What angle is it symmetric with respect to? Well, it's symmetric. These 2 points are symmetric with respect to theta equals 0. These 2 points are symmetric with the point y equals pi, theta equals pi over 2. Okay, I'm trying to figure out where that one is.
Well, that would be two as well.
These are symmetric with respect. All right, so theta plus pi. Whatever theta is, you add pi to it, and that gives you this angle. And so I add those two together and divide by 2. So that's going to be half a theta plus half a pi. Right? No, that's going to be theta plus half a pi. Yeah. So if I go half a pi this way, then whatever angle that is, that's where it's symmetric with respect to it. So if it's theta and negative theta, right, then it's going to be symmetric with the polar axis, either the positive or the negative. Well, the polar axis, that's this whole thing. If the 2 angles are theta and pi minus theta, then they're going to be symmetric with respect to 2 pi, pi halves. If the 2 angles are pi apart, then they're going to be symmetric with respect to the pole, right? Because it's r this way and negative r this way. So 3 pi over 2 and negative 3 pi over 2, which is 4 pi over 2. Okay, so when you look at the coordinates, you need to, the r has to be the same. And then do the 2 angles fit this pattern. So here I have, is that, no, this is 3 pi, pi over 3. So this would be negative pi over 3 or 5 pi over 3. because each one of those is pi over 12. 2, 3, 4 pi over 12 is 1/3 pi. Okay. Test for symmetry. If you replace pi theta with negative theta, and the equivalent equation results in the graph is symmetric with respect to the polar axis, which is the x, also the x-axis in the coordinate plane. If theta is replaced with pi minus theta, and you get an equivalent equation. In other words, if you simplify it, you end up getting the same equation. Then it's going to be symmetric with respect to the line theta equals pi over 2, or the y-axis, the coordinate y-axis. And there's one more page, and I'll let y'all go. Test for symmetry being if it's symmetric with respect to the pole. If you replace r with negative r, or not and, or you replace theta with theta plus pi, and you get an equivalent equation, then it's gonna then it's symmetric with respect to the pole. And when we start graphing polar equations, we have certain types of polar equations, some that look like hearts, some that look like propellers or petals of a flower. So that's what we're going to be looking at. We can tell what kind of symmetry it has, and so if it's symmetric with respect to the pole, to the polar axis, then I just need to find the top half, and the bottom half will mirror it. And if it's symmetric with respect to pi over 2, or the y equals, or the y-axis, then you just find one side of the y-axis and map its mirror on the other side. Let me check this out. And then if it's respect to the origin or the pole, then you just graph either above or the x-axis, and then just graph its mirror image to the poles, and then you can complete the graph that way. So we'll start with, so this is where we start doing those things. Cardioid, it's going to look like a heart, and by heart I mean it'll look, it could look something like this. No, that's yeah, that's fine. Or it could look like wait a minute. Let me do it this way. Something like that. Or if it's, I think if it's cosine, it'll be laying on its side. Or this one might be laying on its side. I don't remember right now. So yeah, I've gone over time, which I did not mean to do. So